welcome everyone. We appreciate everyone taking the time to join us on this webinar. Our hope is that it's very informative and prompts questions so that we can provide further information to you for your specific needs. My name is Frank Stokes. I'm the manufacturer's rep for hazard control technology for Florida. So we're down here in hot, sunny Florida, and right now we're having a thunderstorm. So if I cut out, I apologize, but we will pick up as soon as I get back up online. We have made some plans.
If you have some problem, Frank, we will continue talking with other specialists in this meeting.
Right. Okay. So our topic today is lithium-ion battery hazards. We want to inform you of some of the hazards that we've come across and solutions for dealing with them. So what is a lithium-ion battery? It's a rechargeable battery. The lithium ions move from negative to positive during discharge and then back when charging again. They're very, very popular, produce high energy, the minimal memory effects, and a very low self-discharge. So old style batteries would slowly degrade and drop off your charge. The lithium-ion batteries maintain their energy to a certain point, and then it's a pretty rapid drop off there of the energy. What are our concerns? The demand. Lithium-ion batteries you can see almost everywhere today. Usage expands continuously. The diversity of them, they contain diverse materials, meaning it's a multi-class type fire when you encounter them. Lithium-ion batteries emit the toxic gases and the flammable electrolytes. And the energy contain a high level of energy, and you'll be able to hear that in some videos that we'll show you in a little bit further on in the presentation. Like I said, you're encountering an A, B, and C class fires with these batteries. So it's not just a single class fire you're dealing with. How can these fires start? One is the short circuiting. They can become unstable and short circuit. Trauma, drop them. Vehicle accidents, they become unstable. Overcharging the lithium-ion batteries can cause them to overheat, and exposing lithium-ion batteries to high heat can lead to thermal runaway. And we're talking about, high heat when people charge cell phones and they lay them on their bed and under their pillows, placing your cell phones on the dash of your car in the summertime while you're charging them and you run into the store. Those are examples of those things. I'm going to show this video. I'm going to try and limit the sound. And this is about the Tesla accident, single vehicle car accident near Houston, Texas.
Next tonight to the deadly crash involving one of Tesla's cars with an autopilot feature. The car slammed into a tree and burst into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez.
Tonight, mystery surrounding a deadly crash near Houston involving a Tesla Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. 2 men inside were killed. The Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out. Now tonight the question, was the Tesla running on autopilot? Firefighters found the men in the front passenger seat and the back seat. Police telling ABC News there's no indication anyone was in the driver's seat. Authorities say the men had just dropped their wives off at home and wanted to take the Tesla out for a test drive. Evidence at the scene allegedly showing it was going very fast. Just 3 hours before the crash, Tesla founder Elon Musk tweeting, Tesla with autopilot engaged, now approaching 10 times lower chance of accident than average vehicle. And Lindsay, we've reached out to Tesla for comment, but have not heard back. And police are still trying to figure out exactly what caused this crash in the first place. Lindsay?
Gio, thank you. Next tonight to the deadly.
Okay, that video shows you, it was a single vehicle accident. All the guides show that you need copious amounts of water to extinguish the lithium-ion batteries. They flowed well over 30,000 gallons, and you could see that running down the street during that video. Plus, they were on scene 4 hours with those batteries still continuously to burn. So we'll address this a little bit more later on in the presentation. But moving on, we'd like to show you that no matter what the industry is, sorry about that, no matter what the industry is, the lithium-ion batteries are present. So warehouse, automotive, portable power tools, laptop computers, e-cigarettes, so they're everywhere, both in industry and in our homes. So I wanted to say something earlier. You may get, the video may come real slow depending on connections. Once we've completed this presentation, you'll receive a link for the recorded version, and you'll be able to see those videos in a normal fashion. So we do apologize for that. So once again, how popular are lithium-ion batteries? And for most of us, we along with our families probably see them or rely on that technology daily. They're found about in every industry that's out there. So we want to make sure that we educate about the lithium-ion batteries and their hazards, so that you're prepared. So the automotive industry, we're looking at the vehicles, charging stations, the parking garages, dealerships, welding and assembly robots, repair facilities, electric tools and parts suppliers, towing companies. So here's a photo of the charging stations, and what we have found, there is no additional fire protection been placed in these facilities once these charging stations have been added. So we'll show you in some additional videos on conventional ABC dry chemical extinguishers, some CO2 extinguishers, that they aren't the best choice for extinguishing lithium-ion batteries. We're seeing them in transportation where, we're getting all these transit buses, and then they go into these store yards where they go overnight and they charge in the proximity. Lithium-ion batteries pose us a problem because if we can't extinguish the batteries rapidly, then it becomes a giant exposure problem for us in the fire service, where the close proximity of these vehicles parked in charging stations creates extreme exposure problems and a big business loss. On our fire apparatus, this is just a picture of a typical piece of apparatus. All of our portable power tools, lights, all use lithium-ion batteries. This is a video we'll show you on vehicles charged. And as you can see, there's a group of vehicles that are charging here. And I've turned the sound down a little bit, but just to show you the rapid fire spread here. What we want to show you here is just that how violent these batteries turn once they go into their thermal runaway and the fire erupts. I mean, it sounds like a blowtorch there. So then we have the exposure to the truck next to it. And, you know, you have two more vehicles on the other side of that. So it's a continuous problem if these aren't caught early on in the proper extinguishing agent that's used on them. Now you'll see on the vehicle, the truck to the left, once it starts getting compromised, the brakes release and it sort of rolls to another point in this parking lot. So, you know, your exposure spreads then, whether it's up against other cars, up against a building structure, and then the situation just builds upon itself. And there you can see it spreading from the truck to the next vehicle. This is a video of a truck fire, and I'm gonna turn the sound up a little bit and stop talking so you can just hear the batteries. So not only you can see the violent activity of those batteries once they're involved in fire, look at all the toxic smoke. So you're on a interstate, a highway, and all that smoke and all the stopped vehicles that are around that, all those people were exposed to all those toxic vapors. So using the lithium-ion batteries in the aviation industry, they're in the unit load devices, ground handling equipment, parking garages, forklifts, the UPS systems, radars, consumer electronic products. Here we're going to show you a tug that looks up next to a airline or an aircraft, and just watch how the fire attack goes with this. They're using a dry chem unit. Never looks like they get right to the seat of that to accomplish anything. And the exposure on this particular fire is the airplane, you know, millions and millions of dollars. As an exposure loss. So that dry chemical extinguisher doesn't give the cooling that's necessary to try and extinguish the lithium-ion batteries. How we see them in consumer electronics, cell phones, laptops, gaming consoles, power tools, hoverboards, which were a big deal a few years back when they first came out, a lot of charging issues, scooters and e-bikes now, you know, remote control toys, battery backups are very, very big. Here's just an assortment of the different types of batteries that you can encounter. And, you know, these are in commercial applications and in everybody's garage. They come in all shapes and sizes. As you can see here, we have different single chargers, and then we show a multi battery charger up in the top left-hand corner. So you'll see many variations of the lithium-ion batteries. And here are the variations of tools that you'll see. I mean, a lot of homeowners have these combo kits, you know, all have the lithium-ion batteries, all have some sort of single battery charger. A lot of them are now selling the multi-battery chargers. Top right is just a picture of equipment for public safety, fire department uses. Their saws, they got, looks like 2 gang chargers there, portable hydraulic equipment and cutters. So everywhere you turn, you're going to run into these lithium-ion batteries. Forklifts, charging stations. This is a common occurrence. There are no additional fire protection features built into these areas. All right, we're going to show 2 videos here. I'm turning the sound down so I can speak a little bit on each of them. Over here, you'll see the scooter. You'll hear a pop, and you'll see how rapidly this goes from nothing going on to a very severe, potentially severe incident. Dog gets up, adult gets over, comes over and unplugs it. See how rapidly that thing, violent reaction. If that young child was sitting in that room by themselves, who knows what their reaction would have been, how quick it would be to get out of that area. I'm going to show you another one here with a laptop. Very, very rapid development, very violent, and causes a tremendous amount of damage to exposures. Here's this is an e-scooter just out by itself. You go to places where they rent these and there's 50 of them next to each other, all hooked up, charging, waiting. Can find them in people's garages, under their houses, popular in some RVs now. So you can run into these anywhere. Energy storage systems, residential storage, industrial. We see a lot of these now with solar power and wind farms, mass energy storage. We deal with these mass storage areas where power companies are using them to use solar energy or wind energy for peak periods, so they don't have to buy energy from other companies. And then off-peak hours, they replenish these large systems, and just like this cycle goes on daily. Medical industry, big deal with pacemakers, glucose monitors, cameras, infusion pumps. I mean, we've all seen these cauterizers, their mobility scooters, the RFID tags, energy backups. You know, lithium ion are just very reliable, so they're very popular. Mining industry is the same way. You know, navigation centers, forklifts, charging docks, electric tools. And we're going to show a video here, and I'm going to turn it down a little bit. And we'll see this high lift machine. See how quickly that erupts. I mean, really no warning whatsoever. The consensus is that operator was the person you saw sort of at the top of your screen. And now we'll see the workers come in with, I don't know, 7 or 8 ABC dry chemical and attempt to extinguish this fire. You know, fires in these facilities have a big monetary impact. You know, employers lose facilities and products, business interruption, and then you deal with workers maybe not having a place to go back to work to. So I believe there's like 3 of these dry chems operating now, and you'll see several more up into the picture. Looks pretty good right now. Looks like they have an initial knock on this. So really what we were seeing is they had a knockdown on the seat and other plastics around that, but no real effect on the lithium-ion battery itself. And no other fire protection features in this building to be able to combat that. Here we have buses that are in their terminal, and we have lithium-ion batteries. Look at all the dry chemical extinguishers that were used unsuccessfully to be able to put this fire out. So then it transitions from just that bus to that whole facility, that structure's on fire. Listed here, we have some headlines that from 2019 that just give some incidents where lithium-ion batteries were involved. In January of 2019, an airplane was evacuated because of a mobile phone battery. Again, in January, a boat burning battery charging injured 5 people on a boat. In February, a power bank caused a aircraft to be evacuated. In April, Arizona Energy Storage System explodes and caused injury to 8 or 9 firefighters, some career ending. And September, an e-bike, 9 people hospitalized. September, again, an apartment building, 5,000 euros in damages. I think it's like 600,000 US dollars. So significant dollar losses when you're involved with these type of fires and the exposures. And the question is, are you prepared? So we look at dry chemical and lithium-ion batteries. We've seen through the videos, the lithium-ion the dry chemical doesn't remove heat from lithium-ion. We had the reignition, which you could see. There's no toxic reduction using a dry chemical. And it's not effective. It can't extinguish those lithium-ion batteries, as we've seen repeatedly. So here's some battery safety solution tests. It's 182 lithium-ion 18650 batteries. Shows the ineffectiveness of the dry chemical. So just notice continuous application of the dry chemical, the dry powder extinguisher. Showed initially a little bit of knockdown, and then no heat reduction, so it was able to continue to combust and out of dry powder, and it'll continue to go into continue to burn in this manner. The second test, same number of batteries, same type of batteries with wrong one. Why did that? Same test using foam is going to be shown here. Foam forms a blanket, so it's very inefficient at cooling because it doesn't remove heat. It actually encloses the heat. It doesn't allow it to escape. Foam blankets retain the heat. Like I said, it aids in reignition, does nothing to the toxin reduction, and it's not effective. And you'll see in this video what we mean out with foam application. Same bank of batteries, same type, 95% charged. Pretty much continuous flow from this extinguisher. The reaction here compared to the dry chemical seems like it's we have more energy being released here than we did with the dry chemical. The inert gas on lithium-ion battery fires. These gases as extinguishing agents were used a lot in like data centers, where you're dealing with wiring and switching, and not very efficient at cooling. They will not stop thermal runaway. There's a very high probability we'll still have reignition because they can't cool sufficiently. There is no toxic reduction that they provide, and they're ineffective at extinguishing these fires. I mean, basically, it's removing the oxygen out of those atmospheres, those enclosures. This is a video of a robotics lab. Those folks took a break, and while they were on break,
everything was going fine. They left for lunch, and we had the battery explode. And if you notice where that fire came out was exactly where our researchers were standing. It could have been a very bad day. This is an intern from the adjacent laboratory. He had climbed through a window. He was not associated with this project. He was using a CO2 fire extinguisher that was in the area. And as you notice, the CO2 fire extinguisher is not effective in putting out that fire. The safety data sheet had called for a type D fire extinguisher and not to use water. There was no type D fire extinguisher available. One of the things we're learning is a type D and a CO2 fire extinguisher are not effective in putting out these type fires. One misnomer is in lithium-ion batteries, there is not a lot of free lithium, so water is the best.
okay, so they showed that with a CO2 extinguisher, not very effective. But look at all the smoke, all the toxic fumes that person was subject to trying to extinguish that fire. That exposure is pretty significant for those folks. How effective is water? We showed you previously in that Tesla car fire. It calls for copious amounts of water. Well, that sort of set the benchmark. They're saying they used 30,000 and they weren't unable to put that fire out. Some other reports have said the fire was extinguished in like 24 minutes. However, it took them another 3.5 hours just to continually cool it, because when they stopped, those batteries reignited. They had all that runoff, and they were a single vehicle accident in a field up against a tree, but it wasn't a multi-car accident. It wasn't in a parking garage, wasn't anywhere else like that where you had all these other exposures. So copious amounts of water. Water is not effective in reducing the thermal runaway. It doesn't reduce toxins. actually leads in spreading them. And it's time consuming. Runoff is toxic. So what are you going to create in extinguishing that fire? So here's just a picture of the Tesla again, and it shows more than 30,000 gallons of water was used. The
Tesla.
Stop. So anyway, 30,000 gallons of water was used on this, and they really didn't extinguish it. So we're looking here at, what's the main problem to be solved here, and what's happened? External damage or fire, faulty or no safety management system, batteries overcharging. The result is fire from thermal runaway. Your temperatures are above 850 degrees centigrade. You need a strong cooling effect. We've shown where there's a multitude of these extinguishers that are not effective. The result is there's a significant hydrofluoric acid emission. Self-heating of these batteries can be up to 3 weeks. The liability concerns and scene safety with the fire brigade, you're talking exposure to your personnel, exposure to the citizens, exposure to the environment. So F500, the encapsulator technology, we're going to explain what exactly that is. F500 is a 100% fluorine-free, non-corrosive, and 100% biodegradable encapsulator agent. It's a multi-purpose NFPA listed for Class A and B fire suppression agents. It's a combustible and flammable vapor and liquid spill control agent.
Encapsulator technology. The fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the non-polar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So I'm going to go back real quick and just highlight this one area so you can see it.
Micelle.
And luckily I got right to where I wanted to go. Just wanted to show, this graphic again as depicting a single droplet of water. It shows the breakdown on the micelle itself, but I wanted to emphasize this is one drop of water, and there are millions and millions of the cocoon spherical micelles inside of this drop of water. You should see that the exterior, very important to pay attention to that, because we'll link this together so you can see how an effective heat sink that is. So anyway, as the animation showed us here, we have a polar head, which is soluble in water, it dissolves. We have the non-polar tail. It's not soluble, it doesn't dissolve, doesn't like the water. So when the F500 EA droplet is formed, the micelles nearest to the surface, they break apart automatically. Non-polar tails stick out of the droplet, pulling the polar heads to the surface of the droplet, thus forming this protective F500 EA skin. So as you can see, the transition from out of the nozzle and how it transitions through. we encapsulate the flammable electrolytes, rendering them non-flammable. So they also, the F500, the spherical micelles, rapidly reduce heat. This is a depiction, a photo of a battery, a lithium-ion battery that was on fire, had gone into thermal runaway. So you see the image on the right where obviously the cells had failed, they were burning, and where the two red arrows are pointing, that's where the thermal runaway was stopped. It was cooled rapidly enough to where you didn't have the exposure to those cells and the additional fire. So it reduces toxins, including the hydrogen fluoride that comes off. So when they burn, they emit the toxic fluoride gases. And the testing has shown that when F500 is used, these gases are drastically reduced. So how effective is F500 on lithium ion? It rapidly reduces temperature. So we have that cooling, so it stops that thermal runaway. It encapsulates all the electrolytes, reducing the possibility for reignition, encapsulates the toxins, so limits that exposure. And it's highly powerful and it's fast. Use less water, less product, so you don't have the runoff or the containment issues. Some comparative testing to lithium-ion batteries. So you can see here and listen, I turned it down some, but you can still hear how violent these batteries are when they burn. You've already seen really the two agents, the powder and the foam. The agent being applied to the right, F500, is short spurts. The other two agents were applied with continuous stream, very short bursts with the fire extinguisher, and it rapidly cooled that and suppressed that fire. So that testing was done by Kiwa, published by Johnson Controls. And basically, here's an overview of what their findings were. The dry powder extinguishers, do not apply them on dry chemical. Foam extinguishers, not recommended. F500 can be recommended to apply to lithium-ion battery fires. And basically, it says the same thing in here. It's the same summary of what I just told you about, that the F500 can be applied. Here's a pouch style battery. We'll show you the effects of F500. And if you notice, the application of the agent is really going to be exterior of this. It's going to be on the outside of this pouch, and just watch the effectiveness of it. Another application again, and seeing the agent as actually on the outside of that patch style battery, but was able to cool it and drop it below the ignition temperature for the thermal runaway. If you watch this one, this is another pouch type battery. If you look at the two nozzles and where they're directed, you'll see they also will not be able to get right inside the pouch, but they're more around the battery itself. See the pouch is venting. kind of hard to see initially, but you'll see that these nozzles are directed really at the frame, but they were still able to cool that pouch enough to drop it below its ignition temperature there. Right, this is a pretty long video, and I'm going to speed through it. Just want to point out a couple different things. You have multiple images on the screen. The batteries tied with thermocouples. There are two nozzles that are fixed above the battery, and they're just connected to an extinguisher. The top right is a thermal imager, and the bottom right is just measure the scale, the graph measuring the thermocouple readings. So I'll get this started. Why is it doing that? So I'm going to speed through this. As you can see in the top left, little wisp of smoke coming out. Pay attention to your graph on the right. You start seeing some changes in the temperature. Top right, you start seeing on the thermal imager, the heat starting to build up. And you see on the graph just below that, the rising temperature. Still nothing really visible from the outside. Now, right at this point, we start seeing some open flame. We see our temperatures increasing. And what I want you to pay attention to is as those temperatures increase and we reach the max temps before the agent is applied, I want you to pay attention to the rapid drop in temperature, how fast it is once the agent starts being applied to the batteries. So we're at 800 centigrade, 500 on one of the other thermocouples. And then here shortly, you'll see the agent being released in the bottom left. But just keep an eye on all those temperatures on the right. Agents being released. Look how rapidly they're dropping. Significant cooling taking place very rapidly. So engineered solutions with F500. You know, our solutions, we provide education. We educate, you know, company employees, fire departments on lithium-ion batteries, technologies, and their hazards. We provide training, how to approach and deal with any incident that you think you're going to encounter. We have encapsulator technologies, a great choice, listed by Johnson Controls, with Bosch, Tesla, as many other industry leaders use our product. And mobile and fixed systems equipment we offer. You know, from 2.5 gallon fire extinguishers to 100-liter carts. So we have a lot of versatility in what we can provide. Fixed systems, we have engineer and custom loss control solutions. We have their powered, non-powered system to integrate into existing sprinkler systems. And the tank sizes range from 36 gallons to 12,000 gallons, with ratio controllers from you know, 0.25% up to like 3%. Our concentrate control supply systems are, you know, we have bladder tanks, water-driven proportioners, pump systems, and custom configurations as they're needed. This photo just shows us sprinkler risers, and to the right is a bladder tank that has the ability to support these risers with the F500 product. I want to show you another system that we have available to us. It's called the Fire Rover. Very interesting concept and how it operates. And I'll play the video here and we will.
Fire Rover is the revolutionary way to stop fires before they begin. Using military-grade thermal cameras to detect abnormal heat variations and up to 20,000 gallons of firefighting agent, Fire Rover protects your business from property loss and downtime. Here's how it works. The thermal camera detects changes in surface temperature. Abnormal heat triggers an alarm and alerts Fire Rover's live monitoring station. Trained operators evaluate the risk and can trigger the firefighting agent remotely within seconds. Operators aim the firefighting agent using both thermal and HD footage. The firefighting agent is 100% biodegradable and effective on metals, petroleum, plastics, agriculture, rubber, general waste, and more, including lithium-ion battery hazards. Fire Rover can reach a distance of 150 feet with a radius of 343 degrees. The thermal camera confirms when the fire is extinguished and the surface has cooled, eliminating the need for costly fire watch. Fire Rover is always ready to detect and extinguish fires and keep your operations safe. Contact us today to start protecting your business.
So that's an interesting concept that we have there, dealing with different industries. The question is, are you ready to encapsulate the world? F500 is being utilized by industry leaders around the globe: Tesla, BMW, Porsche, GM, Duracell, Jaguar, Johnson Controls, Bosch, and Panasonic. So a lot of heavy hitters in the industry use our product. And what we've added here is, we'd like to thank you for your attention today and taking the time to join us. And it's time that we wake up for new technology in the public safety arena and look at new products that can assist us with our everyday occurrences or incidents.